Welcome everyone to Advent of Code with Pandas. My name is Teddy Petru, and this is where I showcase advanced Pandas tricks to solve these problems. All right, we're on day 7, and here is our input data. So the data here is a list of file system commands and their output. So if you see a line that begins with a $sign, that line is a file system command. Anything else is just a list or some output from that command. All right, so there's not too many commands or outputs, thankfully. I'm going to actually go through all of them. There's a cd command, and that'll change directories into that directory. There's an ls command, which will list the contents, so everything below it that does not have a $sign is just the list of the contents of that current directory. And then you'll have a cd ... command. This moves up one directory in the file system. All right, so those are the commands. And so the list of the contents, you'll either see a directory or a file. So directories begins with dir, the name is to the right. A file has its size and then the name of the file like that. All right, so our job is to find all directories with a size less than or equal to 100,000 and then sum them up. All right, so this problem isn't quite possible with Pandas. We're actually going to create a tree structure similar to this, where each of these blocks is a node, and each node has children that can either be files or other directories. So not exactly like this, where D is directory, F for files. The directory can contain a mix of directories and files. All right, so the way we're gonna do this is we're gonna create a Python class, a node, that will be able to handle all of this. So each node will have these 5 attributes. So it's a pretty simple class. It will have a parent, which will be of type node. The children will be stored in a dictionary of nodes. So we'll use the name of the directory to reference it, and then the values will be the nodes themselves. Each node will have a size. It'll have a total size as well. So total size is if it's a directory, and you want to find, you want to count up all of the files and directories with all those files underneath it. So this is a little tricky to compute. I'll show you that down below. And then we'll just have a Boolean whether or not it's a directory or not. There's only 2 types. It's either a directory or a file. All right, so let's see how this is done. So we're just going to iterate through every line in the file. We're just going to sort of do some hard coding here. We're going to sort of set the problem up. So the first line, it will be cd, let's go back over here, slash. We're going to create the top node over here. This is the only one that will not have a parent. The children will, for now, be an empty dictionary. All directories have a size of 0. That's just the size of the directory itself. But the contents within the directory will have a total size, and we'll be adding that together as we see. And this is a directory, so that is set as true. I'm going to just create a sort of a global dictionary, if you will, that will have this is sort of like maybe even the top level node, I guess you could say. It's just a dictionary that says the /, this is the top folder, will point to this top node. All right, this is just so I can reference the very top of this file system. All right, then I'm going to go line by line through the file, and then I am going to strip off the last character, which is a carriage return. So I'll have that current line, and then the current line will be one of 5 different cases. It's always one of these 5, so I will do something different for each one of those 5. If it is ls, I will actually do nothing. If it is cd ... that means it goes up one directory. So what I'm going to do here is I'm going to take the current directory, and I'm actually going to point it to its parent. Right, so it's going to go to its parent. The first one doesn't have one, but all the others will have parents. If it's CD, if it's any other CD, that means that I will get the directory name because it begins at character 5. So let's go back up here so you can see that. So this starts at character 5, and to the right, I will get that name over here, and I will change the current directory to that child. So right, the children is a dictionary of directory names that are mapped to nodes, right? So you can see here in the type hint, it's a directory of strings that are mapped to nodes like that. So that's all I'm gonna do. I'm just gonna change, because I'm seeding, I'm actually literally changing the directory. If it starts with dir, that means it has followed an ls. And now I'm just gonna add to those children. That's all I'm doing here. So the first thing I'm gonna do is get the name of that directory that's been listed. So I'm just gonna split the line on a space, select the second item. So let's just see an example of this. So here it is. Here's a dir right here. So it's gonna split right here, and then it will just select that name, and then it'll just add it to the children like this. So I'm just gonna create a new node where the parent is the current directory. We don't have the children yet. The size will be 0, the total size will be 0, and is the directory. And I'm going to assign it to that children, to that children dictionary, right? So I'm just adding. All I'm doing is adding to that dictionary of children like that. Anything else, it is a file. So I could have created a specific statement right here to conditional to check, but I know that there's only 5 possibilities. So if it's anything else, it is a file. So let's take a look at a file over here. So here's an example right here. I'm going to split it on the space. I'm going to convert this to an integer, and that will be the name. So that's what I've done over here. I unpack it, convert the size to a name, and then I'll create a new node. Its parent will be the current directory. It's not going to have any children because it's a file. You can't have directories inside of a file. The size will be that integer over here. Its total size will be the same. And then it is not a directory like that. And then I just make the assignment like this. I'm just adding to the children like this. Now, the final piece is, if it is a file, what I need to do is accumulate that size in the current directory and all the parent directories, right? So the size of a directory is, say the top one, is not only the size of the files directly underneath it, but all of the children that come beneath it. So it's a little tricky, but what I'm going to do here is I'm going to traverse upwards. So I'm going to find the parent of the, of this file. And while there is a parent, that's all this is saying, I'm going to change the parent size. So the parent is always a directory, and I'm going to add the size to the total size. And then I'm going to find the parent of that parent and keep going up. So once it's none, this loop will break. So that's all I'm going to do. I'm kind of just adding this file to this directory, and then adding it to that directory as well, and any directories above it. Okay, so let's go ahead and run this code. And so if you look at, so here's top directory. This has all of the information, and it's not easily printable, so you can't see what's going on. But I created this loop, this function, which will print out these directories. Let me just run it first, and then I'll explain it. So you can see how you can see the file system. This is the entire file system. So I made a nice printout over here. So all I'm doing is iterating through this dictionary of strings mapped to nodes. And then I'm just going to print out the name of the node size, and then the node total size. And this here is just a tab character, and I'm just going to increase the indentation as the level increases. So this is a recursive function. If there are children, it's going to call itself. It'll just pass in the children to the node dictionary, and then it'll just increase the level. The default level is 0, which is why it starts out over here at the beginning. All right, so hopefully that explains that. So that's all. This is just a nice visual representation of this directory system. All right, now what I need to do is find all of the directories that have less size than 100,000. And so this is actually pretty tricky. I'm going to have to call another recursive function here. And just what I'm going to do is just get all of these directories. I'm not even going to get the name of the directory. I'm just going to get the size, and I'm going to just continually to append it to a list. All right, so let's just read through this here. I'm going to pass it that top level dictionary. I'm going to iterate through all the items, only if it's a directory here. I'm not looking for files with less than 100,000. I'm going to append to this size list, whatever the size of that directory is. And then I'm going to iterate through all of the children, and I'm going to recursively call this on all of the children, passing in this list, so it will get continually appended in place. And then I'm just going to, at the very end, I'm going to return this list as a pandas series. And so let me just comment this out. And so I can show, here's my pandas series. So this is, I don't know the name of the directories. I don't really care for this problem, but I have a list of all the directory sizes like this. So that's what we have here. The next thing is just to filter for all the ones that are less than 100,000. So this is where I finally get to use pandas, and then I will just sum these up and get the result. All right. Whew, that was a long one. But let's just review this real quick. The trick is to, create this node class that references both parent and children. So this is the main step. You can obviously add other attributes as well, but this is sort of the main point, is how do you create a node that references other nodes? And we do it with parent and children like this. You could have made this a list of children as well, but I decided to use a dictionary. All right, so let's go down here. The last one, 7b, the second part of this is saying that there is a total, this is total space in your file system of 70 million. We're just going to use the, we're going to figure out how much space is left by doing this. So really just looking at that very top one, right? So that's how much space is used. So that's like 44 million. And then what we have to do is figure out, we want 30 million left. We want at least 30 million space left. So we need to figure out which ones to delete. We want to delete one directory that will give us with 30 million left. So we just do a little bit of math here. And we need to find a directory that has, looks like about 4.8 million, the smallest one. We want to delete the smallest directory with 4.8 million. That will give us at least 30 million space. So what I've done here is I've just, for any directory that's less than this val, this is where I use a little bit of pandas. I am masking it, which means I'm making it nan. I don't care about that. And then I'm just going to take the minimum. And so this is the smallest one that is less than this or greater than this value. That'll give us just enough space. And that is the answer for that. All right. So hopefully you enjoyed this one. Very long problem, doesn't really use a whole lot of pandas, but maybe you learned something new about creating, trees that, reference nodes that are of the same type. All right, so that's it for Advent of Code Day 7.